In our last videos, we've been talking about how different LLMs, the current AIs, are with potentially the future next generation AIs, as in AI, AGI, and ASI, in that there are a lot of components that are missing, for example, with these LLMs, one of them being the specific characteristics that a human brain has that, for example, the current narrow AIs do not have. And for us to be able to go to the next generation of AI, as in AGI, for example, we do need to include those components in the future of AGIs and AIs as well. One of them being reasoning, because the human brain, for example, automatically does, for example, reasoning really well. And this is something that is, among other characteristics, that is missing from the LLMs. And so for an AGI to be an AGI, it needs to be able to do the reasoning, meaning that it needs to be able to autonomously think for itself, adapt to different situations and environments, and do like the human brain does when it comes to reasoning. We also covered last time how that reasoning happens at the brain region level, but in this particular video, we're going to look at how reasoning happens at the brain waves, or the electrical activities of the brain, when it comes to reasoning of the human capabilities. To recap from previous videos, for the next generation AI to be considered as AGI or even next gen AI, they do need to have several components. One of them being, as mentioned last time, they need to be able to generalize across domains. They also need to reason and solve problems autonomously, adapt to new experiences, understand and interact with the world like we humans do, and lastly, exhibit autonomy in long-term planning. And so reasoning is something that is one of those components that could be potentially added to this potential next generation AI, mainly because if we are to mimic, to build something that resembles the human brain, reasoning definitely needs to be one of them. And in reasoning, for example, we need to first identify and define problem. We need to generate multiple hypotheses about that problem. We need to apply logic, learn and adapt, and we also need to handle ambiguity and uncertainty. These are the things that you and I as humans do at any moment in time without us even thinking about it. However, when we want to build machines, we do need to think about these different components. As mentioned, when it comes to LLMs, they definitely do not possess reasoning, which is one of the characteristics that human brain does. But when it comes to AGI, which is the potentially next generation AI, what are the key differences between human versus AGI reasoning? In humans, reasoning is deeply connected to emotion, past experiences, and context. We reason not only with logic, but also with our intuition, with our biases, and with our learned behavior based on past experiences. In contrast, in the AGI, next generation AI, it would need to separate its reasoning from emotional biases, relying purely on logic and data, unless explicitly designed to simulate emotional reasoning. Humans are also sensory input, such as sight, sound, or touch, and embodied experience to reason through problems, while in AGI, they might possess data in a different, more abstract form without direct physical interaction with the world. Having said that, I literally this morning read about a new technology that Meta is introducing and just launched, in that the AIs now are being trained through sensory output. In other words, they make sure that these AI systems that they're training, they look at visually around the environment, and not only through the language and text, which we've been training LLMs with, they are now being trained from the visual perception that they are gathering from the world. And that's exactly how the human brain is also designed to do. So that was a very exciting release that I can talk about more about that in the future if you guys want. So last time we talked about how reasoning happens within the human brain on the different brain region level. And today we're going to talk about where that reasoning happens at the brain electrical activities, aka the brain waves or neural oscillations of the brain. So brain waves represent the electrical activities in the brain, and they vary depending on the type of cognitive tasks that is at hand. Different brain waves are associated with different states of thinking, from deep relaxation to intense concentration. But when it comes to reasoning, there are certain brain waves that play a key role in how we process information, make decisions, and solve problems. So how do these brain waves work then together? The reasoning that happens within the human brain often involves the interplay between different brain regions and different brain waves frequencies that support different phases of the reasoning process. For example, alpha waves might allow for focused attention, helping to sift through relevant information, where theta waves might enable creative association and new solution when it comes to reasoning, and beta waves might be the active partners where we engaged in detailed reasoning or problem solving. And lastly, gamma waves, which is the highest frequency, help integrate these ideas into coherent thoughts or decisions. And so a typical reasoning cycle within the human brain when it comes to the brainwaves frequency might look something like this. We start with a task where we might start with the alpha waves that helps us relax and focus to prepare to engage in a reasoning of a task. And then we move on to the creative insights, where we explore the problem at hand. Theta waves then could emerge, helping us come up with creative ideas and solutions to that problem. Then we go on to the focused analysis phase, and that is when we start settling in a problem or a solution. In this case, beta waves frequencies become prominent as we engage in an intense, focused reasoning, and where we weigh our options and where we consider logical, hopefully, consequences. The next phase could be the integration of information, where we synthesize our thoughts, where gamma waves come in. They help us link together abstract ideas and integrate knowledge from different parts of the brain. And lastly, the subconscious processing and reasoning could be that there's a downtime or a rest time where delta waves might continue to integrate information subconsciously, leading to insights that emerge later on for us to go through this reasoning process, cognitive process within the human brain. In other words, to explore how reasoning happens at the brain waves frequency level, we do need to understand both the brain regions that are involved in reasoning and the specific brainwaves frequencies that accompany these cognitive processes within these brain regions. We do have research in this topic, scientific research, peer-reviewed, that spans from neuroimaging studies to EEG analysis that measure brainwaves activities. Several studies using EEG or fMRI have shown how brainwaves frequencies correlate with reasoning. EEG studies that have demonstrated that beta and gamma waves frequencies are particularly prominent when individual engages in tasks requiring logic and abstract reasoning. These brainwaves increase during tasks like solving math problems, for example, or playing chess, or completing logical puzzles. Frontal theta waves also shown in research studies that they are particularly in prefrontal cortex and are involved with individuals who engage in working memory tasks and or attempt to retrieve information from memory to solve problems. Other studies published in Journal of Cognitive Neuroscience highlight that gamma synchronicity, they are the highest brainwaves frequency, by the way, play a key role in coordinating information across the brain's networks, which is crucial for tasks for reasoning, insights, creativity, and so forth. These research studies indicate that synchronized neural activities in the prefrontal and parietal regions boosts cognitive performances, especially in tasks involving abstract. As a whole, reasoning involves a complex interplay of different brain regions as well as different brainwaves frequencies. The brainwaves beta and gamma in particular are the key players in higher order cognitive functions like reasoning, decision making, as well as problem solving within the human brain. These waves provide the necessary neural synchronization to integrate diverse information and draw logical conclusions. The regions involved, such as prefrontal cortex or parietal lobes, coordinate the process by handling memory, abstract thoughts, and executive control. And understanding these brainwaves frequencies as well as these patterns and the brain regions that are responsible for reasoning can provide incredibly valuable insights into how both human intelligence and the future of AI, as in AGI, might. So, in designing the next generation AI, and for us to be able to include the typical characteristics of a brain, one of which is reasoning, we also need to know the process. That is why knowing these step-by-step processes as to how these brainwaves frequencies shape the reasoning that is happening in the human brain is extremely important, because when we break things down, then we might be able to incorporate these type of step-by-step levels and processes that are happening in our design of the future next generation AI, as in AGI and AS. And so the process in which the brainwaves frequencies shape reasoning within the human brain, that might be extremely important in designing the next generation AI, as in AGI and ASI, could be simplified more or less to 5 steps. The first step is the initial phase. That is when we begin solving a problem or thinking a thought of a complex idea. Here, the alpha waves frequencies might help us focus and reflect on that problem, which allow us to access relevant memories and concepts in order to tackle that problem. Our brain is then relaxed, yet in an alert state, preparing to handle the task. Next step is the active reasoning. This is where we move into a deeper problem solving step where the brain produces beta waves frequencies that represent focused and mental effort state. These waves are particularly active in the prefrontal cortex, where complex decision making and analysis occur. The third step is creative insights and idea generation when we are doing the reasoning. So when we start thinking, for example, outside of the box or coming up with novel ideas, theta brainwaves frequencies might come into play. They are linked with creative insights that can help generate possible solutions or ways of thinking about the problem at hand that is not immediately obvious. The fourth step is the synthesis and integration, where we, as a human brain, integrate the different pieces of information to come to a conclusion. Here, the gamma waves frequencies, which are the highest frequency, might help synchronize various regions of the brain, where these waves help coordinate higher level processes, such as combining abstract concepts, pulling from different memories, and integrating sensory data to form a unified idea or solution. Lastly, is the last step of the human reasoning with brainwaves frequencies in mind is the final decision and conclusion. This is once a solution is found, delta waves frequencies may briefly take over, representing deep subconscious processing. And this can happen when, for example, we're wrapping up the reasoning process and are about to take action based on a decision we just made, or when the brain integrates information that was previously out of their conscious. So the big picture of the brainwaves frequencies of the human brain when it comes to reasoning that might help us design the next generation of AI, as in AGI and ASI, in a more human-like manner, is that brainwaves reflect the neural synchronicity that underpins reasoning of the human brain. They allow different regions of the brain to work together efficiently. They coordinate like an orchestrated effort various cognitive functions involved in problem solving, decision making, and creative thinking. And so for AGI, which would be the potential next generation of AI to mimic the human reasoning, it would need to not only simulate the cognitive processes, but also recreate the brainwaves dynamics that allow these processes to occur efficiently and effectively. That's all I had for today, folks. For the next round, we're going to continue with covering the specific characteristics that the human brain has that the current AIs do not have. For example, problem solving, creative thinking, emotional intelligence, and so forth. This time we covered reasoning, but we're going to continue with the next characteristics moving forward. I hope you found it helpful. Please go ahead and like, share, and subscribe to increase the engagement. Thanks. Bye.